Okay, so the third week of classes just ended, right? And I already have like 10,000 different projects. So, I hope you guys would bear with me as I like spew out the stuff to you in hopes of like clearing my mind of some things. And I mean, I don't know. Well, I guess I won't spew out everything because, some are like kind of secretive, not really. Whatever, I never signed a non-disclosure claimer. Anyway. But no, I mean, I don't know. Let's go through this thing. So here, like I actually recently just started this, like earlier this week, and like you could see there's like a ton of stuff, classes, clubs, ZAFs, which is my material science project, and then it's just so many things, and then that's it. Okay, you wanna start? Let's start. So first, right? E&M. Well, I guess classes don't really count as projects. I guess you could like count the entirety of classes as projects, right? So I'm taking E&M, thermodynamics, which is a material science class, which I'm enjoying really much actually. Like I'm not enjoying the calculation part, but I'm enjoying the part where the professor's like, "Oh, right, like this is how everything fits together." I mean, I don't know. Thermodynamics is hard. It's just there's like way too many variables. There's entropy, enthalpy, Gibbs, free energy, Helmholtz, pressure, temperature, moles, volume. And then like if you want you could throw in all this like specific pressure, not specific pressure, specific volume, specific um yeah, heat capacity is also another one, and then there's like specific entropy, specific enthalpy. So specific, it would just be like those individual variables divided by mass, but there's like too many variables to keep track of. Anyways, that's thermal. Theoretical computer science is pretty fun so far, actually. It's pretty easy. It's really easy. Like, if you understand logic and stuff, it's like, oh, right, that's the definition. I'm not gonna argue with that. Like, I mean, it's counterintuitive, but, if you define it that way, sure. Okay, class, lab. Okay, let's come back to lab. And then I have laser physics. That class is a pain. So it's an undergrad grad mixed class. So it's listed on our like how do you describe it? Like the information systems. We call it the student information system, SIS. I don't know what other schools call it, but it's basically the system where you go in and register for classes and stuff, right? And so on there, it's listed as both a 300 level class, which is, a really upper level undergraduate level class, and a 400 level class, which is a graduate class. So I think the professor is going to be treating everyone in that class like graduate students, and my physics knowledge is nowhere near where he thinks like my physics knowledge is right now. So that's always fun. Okay, let's come back to lab. That class, we're 3 weeks into this experiment. I've collected a lot of data. So the class is set up to be where you walk in and the professor hands you a set of equipment and, like tells you to measure this thing and basically says, go for it. So we spent the entire first lab section coming up with a plan of like what and how we're going to be doing the experiment, yada yada yada. We've modified that procedure a ton of times since, but like it is a 4-hour lab, Tuesday, Thursday, so technically it's 8 hours per week. It is a like really long lab, but it's just I can't 3 weeks into this thing, and I still don't know what our data even means. I need to figure that one out. We still have 2 more weeks though, so that's good. But I don't know what the data means. Like we are doing birefringence, which I don't know if you guys know, but it's basically the property of certain materials that it could refract light differently depending on its different polarizations. So so vertically polarized light would travel through differently than horizontally polarized light. And yeah, we've been measuring the intensity, like the intensity of light going through versus the like a voltage on like our calibrated data, and all of that versus the temperature on our sample. Yeah, that's like, a three-dimensional space plot that I have to figure out what the heck is going on. And the main goal, at least for me, is to figure out what's going on with our sample during its critical temperature, which is where it undergoes its phase transition. But yeah, anyways, like, Case's physics department has this entire lab system set up. So freshman lab, you get like really detailed instructions. Sophomore lab, it's more like, oh, this is the big picture, and like here are the steps you should follow, but you don't have to follow it. But if you follow it, like we generally did because we had no idea what's going on. And junior lab, which is a lab I took last semester, which was basically, like these are the things, here are the variables you should measure, like this is the procedure you should follow. But like, it doesn't give you any details for a lot of it. And then senior labs, like here's the equipment, go for it. The what? And apparently all of this is to prepare for our senior project next semester, which will be, I'll talk about it later, I promise. But, so like the senior project is basically going to be more open-ended and stuff. Classes aside, how long have I been talking? I've been talking for 6 minutes already. Okay, let's move on. So clubs, autonomous vehicle challenge. That's a thing. There's really not a lot to talk about. I guess I could show you the videos. I don't feel like editing this video. So we have our sensors working, and now it's like the autonomous vehicle challenge is we're supposed to navigate a field, and the vehicle is supposed to like look at, like see specific things and turn and stuff, like it's supposed to loop around the field. It's going to be outside in a parking lot. And so we have our sensor working to where it could see the color, and if we turn the thing, like the sensor and the platform, the Arduino, we're coding in Arduino, if we turn it 90 degrees, it tells it to quote-unquote stop turning, which, like we've got that system set up. The mechanical side, we laser cut our base this past week, but besides that, the mechanical side hasn't made a lot of progress. Okay, rocket team. So let's talk about lander first. I'm supposed to be SolidWorks in the door, and I don't know. So the objective of the lander is to launch a rocket, deploy a lander, and it's supposed to land self-right, and take pictures and send data and stuff to the ground station. That's the objective. We've been working on this for quite a while. And like I don't want to give out designs yet. Maybe afterwards, just in case other teams are watching. No other teams are going to be watching this. The CDR is due next week. Yep, that's a thing. No, the CDR was due. We're giving our presentation next week. That's a thing. Rocket Team PR. So we're doing 3 different outreach events this semester. I think I've got it like mostly figured out, so that's good, but I still have to go out and buy cardstock paper and tape. So we want to have little kids quote unquote build their own rockets with paper and tape. And then so for next week it's the engineering carnival, so I'll probably talk more about this. But so you remember last year we built hoop gliders, which are essentially, like ribbons of paper taped on a straw. So that's what I did last year, but this year Rocket Team wants to do catapult rockets. I'll talk about it more next week, but that's a thing. And then we're doing a thing with SWE, the Society of Women Engineers, for Girl Scouts. And so last year we also did this. It was the Alka-Salsa rockets. And I think this year is probably going to be around the same. And we're doing a Big Brother Big Sister outreach this year. I don't know. That's in April. It's too far away to worry about right now. Okay, ZAFs. This is going to be my senior project. I don't know. I have no idea what's going on, really. So the professor actually, we chatted this week, right? And she was like, oh, yeah, even if you don't get the funding, that you applied for, well, that we're going to apply for, I could still find the cash to pay you. And so I suppose my summer, like my summer is finalized. I'm going to be staying in Cleveland and maybe going down to Columbus, Ohio to meet one of her colleagues and work there a little bit. Cool? Yeah, that's a thing. I have no idea what's going on. Quantum macro quantum. Oh my goodness. So, my discrete math professor / Java professor, you remember how I did that video about quantum? Yes, that's a thing. So yeah, I've been meeting with him for the past 2 weeks now, and like trying to explain quantum to him. I'm kind of being able to convey my ideas to him. He says he has intuition for the subject, which is good. Like, I think he mostly wants to do it to develop some like classical algorithms, but that could like theoretically, like he wants to program something classically to do quantum, algorithm stuff, which is like, I mean, I don't know if it would work or not, but I'll tell you about wave functions, That's like probably the last thing he wants to know also. But I mean, like last week, I think he liked it. I kind of blew his mind with a thing that you guys won't understand, so I won't even tell you guys about it. I mean, if you guys want to know about it, ask me in the comments and I'll tell you about it down there. Chris ODE. So the differential equations numerically thing, I'm kind of doing it still. I'm not really. I do it whenever I have free time. How about that? HPCC, same story. Oh, Chris wants to do, if any of you guys are interested, by the way, and if you guys have like Lego Mindstorms laying around, and if you guys like coding, actually Nathan, I'm looking at you here. If you want, there's a professor here that wants to try to code Lego Mindstorms in Java, and he wants to show it, like he wants to do like a live demonstration of it in class. Just throwing that out there. Anybody can pick it up. I'm sure he wouldn't mind. Okay. Others. Saturday videos. Look at that. That's a thing. Idea by Monday never happened. Video plan by Wednesday never happened. Film. I guess it's this Saturday and I am filming. Whoops. Okay, so, and that's it actually. Yeah, and also for next week, so I nominated a professor to win this award, and he got it, and then they want to interview me and be like, hey, so why did you nominate this professor? So there's that. Okay, well, I've been recording for 13 minutes. I will see you all next week.